Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in Ajay Kumar Garg Engineering College, Ghaziabad. So today we are going to discuss about a computer networks topic, that is on the network layer is Internet Protocol. When I'm talking about the Internet Protocol, it means I'm talking about the IP protocol, right? So when I'm talking about the network layer, we know that we are using an logical addressing or IP addressing. So into that case, when I'm talking about the Internet Protocol, before we move towards the Internet Protocol addressing, so we should be aware about what is an Internet Protocol. Remember one thing, whenever I'm talking about the Internet Protocol, we always used to say that it is a delivery mechanism which is used by the TCP IP protocol. When I'm talking about an Internet Protocol, it is having a two versions, that is a version 4 which stands for IPv4 and the second version is called IPv6. When I'm talking about IPv6, it means it is a version 6. This particular version is also called as a IPNG, which stands for Internet Protocol Next Generation. When I'm talking about the Internet Protocol, we always talk about its two properties. The first is it provides a best effort delivery. Right? When I'm using the when I'm using the word best effort delivery, it means this particular sends the packet with no errors, right? And simultaneously no flow control. Means we are providing flow control, better flow control also, right? And the second property is called as a reliable protocol, right? When I'm using the word reliable, because it is always merged to work with a reliable protocol, that is a TCP protocol. It is being paired with the TCP protocol to transmit the data, right? So here we are going to discuss in this section, we are going to discuss about its IP header format. Then we are going to talk about the fragmentation, how the fragmentation takes place. And in this case, we are going to talk about the checksum method, how the checksum works in the case of Internet Protocol. And finally, we are going to talk about the different options, right? So before that, we should be aware about the position of IPv4 protocol in the TCP IP protocol suite. See, when I'm talking about the TCP IP protocol, so into that care, we are dividing the complete figure into the either in a 4 or a 5 layer architecture. Right? So if we are talking about the network layer, under the network layer, this is the position of IPv4. It never works alone. It always merges with the different protocols, then only the IPv4 is used. So in the case of network layer, if I'm using about, so it is merged with either ARP, RARP, ICMP and IGMP. These are the various types of protocols through which we are using the IPv4 or IPv6 protocol, depending upon which type of a version we are using. Then after that, we are going to talk about the transport layer. So generally, we are using the IP protocol with the TCP IP protocol, right? So this is the position of IP protocol. Now here, first of all, we are going to discuss about the IPv4 datagram format. When I am talking about any packet which comes from the upper layer, right? So suppose when the packet is coming from the transport layer, it is coming as a complete data. And when it comes to the network layer, after coming to the network layer, it is the responsibility of the network layer to include its header and simultaneously its data, right? So into that case, when I'm talking about, so first of all, the complete datagram is being divided in the two parts. The first is header format and the second is data part, right? Data means whatever the data we wants to transmit it. So whenever we are talking about the complete size of this packet starts from 20 bytes up to 65,536 bytes long, right? This is the total length of the complete IPv4 packet, into which if I'm talking about the header can variate in the two parameters. Either it should be a 20 byte long or 60 byte long, depending upon the certain conditions. Into that case, when I'm talking about the header length, these all are the various parameters which is being included into the header. So in this case, we are going to discuss each and every parameter. What is the meaning of each and every parameter into the header format? First of all, we are going to talk about the first parameter, that is a VER. VER stands for the version. When I'm using the word version, it means, because we are talking about the version of the IPv4 protocol, so it means it is a 4 bits long. The size of the version is 4 bits long. So if it is a 4 bit long, into this case, if we are using the IPv4 header format, it means we are talking about the version 4. Then in the case of 4 bits long, the value in the 4 bits is 0100, right? But if we are using the IPv6, as I've already told you about the IPv6, so if we are using the IPv6, it means we are talking about the version 6. So into that case, if we are using the version 6, then its value becomes 0110. So this is the 4 bit long version. Then if I am talking about the next parameter, that is a HLEN. HLEN stands for header length. When I am talking about the header length, it indicates into the 4 bits, right? Again, it indicates into the 4 bits. It means we have to talk about the header length. As you know that the header length is either a 20 bytes long or 60 bytes long, right? So if we are talking about either it is a 20 byte long or 60 byte long. Now into this case, if we are representing into the 4 bits, so to make it 20, for those 4 bits we have to multiply by 5, then it becomes a 20 byte long, right? Similarly, for making it 60, we have to multiply by 15. So into this case, the header length is 5 if we are using the 20 byte header length, right? So it means the value of this header length is to be 5, right? If we are using the 20 byte header, we are using the value 5, right? Or if we are using the value 15, it means it is a 60 byte long, right? So if we want to represent into the 4 bits, what is the meaning of that 5? It becomes 0101. This becomes 5, but if we want to make it 15, then the value should be 111. 4 times 1, right? This is the way how we are indicating the header length. Is it clear? Then after that, we are going to talk about the next parameter, that is services. When I'm talking about the IPv4, we are providing the different types of services. Initially, this is the way how we are representing the service type. But when I'm talking about the coming generations, generally we are talking about the differentiated services. Why? We are moving from the service type to the differentiated services, because you can check here some of the parameters is being fixed, that we have to use the toss bits, right? In this case, can you check when I'm talking about the service bits, it is of 8 bits long. If it is a 8 bit long, you can check the 8, it is being shows the 8 bits, right? These are the 8 bits, out of which the last bit is unused. Fine. This is an unused bit. We are not using this bit at all. Then after that, these are the first 3 bits, the rightmost 3 first bits is being used for precedence, which shows the priority of the packets, right? So if we are talking about the 3 bits priority, it means the priority starts from 000 till the 111, right? This is the way how we are representing the precedence. Then after that, we are going to talk about the toss bits. If I'm talk about the toss bits, each and every 4 bit, here we are representing the 4 toss bits, in which we are representing a D, T, R and C. If I'm using the word D, it means if this value is 1, it means we are having a minimizing the delay. We are minimizing the delay into the system. Each and every bit is having a different meanings, and each bit is representing only in the 2 forms, either 0 or 1. Whatever the value is 1, into that case we are talking about the different type of services, right? Then after that, if we are talking about the second bit is 1, it means we are talking about T. So in this case, whatever the data we are sending it generates the maximum throughput, right? Then after that, if I am talking about the next bit, that is R, if it is 1, then it means we are talking about the reliability. We are getting the maximum reliability onto the network. And finally, if the last bit is 1, cost, so it means we are using the minimum cost to transmit the data from source to destination. So when I am talking about the precedence field, here we are talking about the version 4, but the last field is to be never used. Now you can check, these are the different type of services how we have elaborated. Just for example, if all the toss 4 bits, it means you can check from the diagram, if all these 4 bits are 0 0, so it means it is a normal method. How? It is a default method which we are sending the transmission of data. Now if 3 times 0 and 1 we have, it means we are having a minimum cost onto that data, right? And simultaneously maximizing the reliability, maximizing the throughput and minimizing the delay. So you can see only the single position on all the 4 bits is 1. If there is all zeros, then we are talking about the normal default value, right? So this is the way how we are talking about the service type. Then after that, there are the certain default services with the different protocols, right? So say for example, if I am talking about the 4 times 0, we came to know from this table that if we are using the 4 times 0 in the toss bits, it means it is a normal. It is a normal value, right? Due to which, if it is a normal, it means we are using the ICMP and bootstrap protocol, right? Then if I am talking about the 4 times 0 1, it means we are talking about the minimizing the cost. In the case of minimizing the cost, we are using the protocol that is NNTP. This is the way on the different queries, different commands we are using, or we are getting the reliability, or we are talking about delay, throughput and everything, or a normal conditions. So whatever the conditions we have, how we are using the different protocols, or how we can execute the different queries. Then after that, when I am talking about the value, see, after that we are going to talk about the differentiated services. In the case of differentiated services, remember one thing, in this case there are the again 8 bit. So out of that 8 bits, these are the 6 bits combination which provides the different types of differentiated services, and out of which the last 2 bits, these are 2 bits which is to be unused, right? So into that case, when I am talking about the precedence of all these datas, so you can see how the value of these code points is being generated. For example, if the value of the code point is 1, it means we are using an ICMP protocol. If the value is 17, it means we are using UDP. If it is 6, we are using the TCP protocol. Now, so after that, we can say into this, we are using the different protocols. Now, if I am talking about the 6-bit code point, into that case, if we are representing, if the last bit is 0 into that code point, right? So you can see the thing, if this is the 6-bit code point, out of which if we are using 5 times any value and the last bit value is 0, it means we are talking about assigning the authorities, that is an internet. Internet is an assigning authority who is providing the services, right? After that, if we are using about 11 in the last, it means we are talking about the local service or local authority. Okay? And finally, if we are using 01, into this case, these are the temporary or the experimental authorities. Fine. So this is the way how we are representing the different types of services. Now let's move to the header format. The next parameter is we are going to talk about the total length. Total length indicates header format plus data length. So into this case, if I am talking about the total length of the data, then we can say, first of all, we need to know how to calculate the total length of the data. So into that case, if suppose it is being given, the total length of the data is 80. Total length is 80. So out of that, we should be aware about the header length. So for example, if the header length is 20, right? Because header can vary it from 20 to 60 byte long. So if I say कि हमारा जो header का length है, that is a 20 byte long. So we can say what is the length of data? So we can say the length of data is equals to total length minus header length. If we are getting the header length from this parameter, either the value is 5 or 15. If the value is 5, it means it is a 20 byte long. So out of that 80 byte, right, the length of data is equals to 80 minus 20. So how much we are getting it? 60 byte data length, right? So this indicates the total length, out of which you can easily calculate the header length as well as data length. Fine. Then after that, we are going to talk about these three parameters, which is being related to the next topic, which is called fragmentation. That we will discuss later. First of all, we are going to talk about these three parameters, right? So first of all, if I am talking about the next parameter, that is called TTL. So you can also check in the case of header length. See, suppose if says, we know that whenever the data comes from the upper length, so if I am talking about showing the Ethernet frame, in this case, so into that case, if it says कि this is Ethernet की अगर हम बात करते तो it is on data link layer. So we includes header as well as trailer. So out of excluding the header and the this, so it means the minimum length including the padding in the case of Ethernet, that should be somewhere equals to 46 bytes long, right? So it should be less than 46 bytes long. So into this case, this is the way how you can calculate the length. Fine. Then after that, we have to talk about the TTL. When I am using the word TTL, basically it gives a limited time life of that lifetime travel through a packet. So for example, this is a sender and this is the receiver, right? Whenever we wants to send the packet, for example, there is a network in which we are including the two parameters. So we can say one length, then we can say 2, and finally we are having a 3 length. So we can say the value of the TTL should be equals to 3, right? So that whenever it reaches to the final destination, that value of TTL becomes 0, right? Suppose if we say the TTL value here is not 3, it is 2, right? So when it comes from S to X, this value, so it becomes 1 reduce, it becomes 1. Then after that, when it comes to next X, it becomes 0. So we can say up to this point, the packet will only live. It will exist into the network. And if it is not reaching to the final destination and its TTL value becomes 0, then we can say this packet is not to be reached to the final destination and it is being discarded through the network. This is the way how we are talking about the TTL value, right? Then after that, the next field is protocols. When, as I have already told you, when I am talking about the IP protocol, it never works alone. वो हमारा अकेला काम नहीं करता, right? So it always includes the different protocols. You can check in the previous diagram also that IP protocol never works alone. It always merges with the certain protocols, right? So due to which, when I am talking about its header format, it always includes the certain bits for the protocols. So into this case, if I am talking about the protocols, so we can say it always includes the different protocols and it where the data belongs to, whatever the protocol we are talking about. For example, if we are using the TCP protocol, so we have to set the value for the TCP. So here the value represents of 8 bit is to be 6. So into that 8 bits we have to represent TCP, right? So that is the value is 6. Similarly, if we are using a UDP protocol into the network, so in the case of UDP, we know the value is 17. So we have to represent the 17 into the 8 bits. This is the way how we are talking about the protocols, right? And the next parameter is header checksum. If I am talking about the header checksum, remember one thing, whenever we are talking about the header checksum, it always do the calculation of the header format. जैसे for example, if we are using the version 4, so it will include the value 4. If we are using the header length is 5 means the header length is 20 bits long. So it includes 5. If we are using here 0 value, then we have to calculate the total sum of that particular header format, and then we have to apply the checksum similarly which we are using into the data link layer. In the similar manner here also, it checksums the header parameters, whether all the parameters is being fulfilled or not, right? So this is the way how we are talking about the header checksum. Then after that, the next parameter into the header format is header source IP address, and this is the destination IP address. As we all are aware, it means we are talking about the source and the destination IP address. If we are using an IPv4, we all are aware, in the case of IPv4, the address is of 32-bit long, right? So if it is a 32-bit long, if we are using IPv4, and if we are using IPv6, it means it is a 128-bit long, right? In the case of IPv6. Similarly, in the case of destination address, if we are using an IPv4 or IPv6, it should be a 32 or 128-bit long. So it indicates the source address and destination address depending upon which type of a IP protocol we are using, which type of a version protocol we are using, right? Then after that, we are having the last parameter, that is options. This also we'll discuss. Now, before we start with the options, we should be aware about the 3 parameters which is related to the fragmentation. The first is identification bits, which is of 16-bit long, right? The next is a 3 bits which is called as a flag bits, right? And the last 13 bits representation of the fragmentation offset. One after another, we are going to discuss about all the 3 parameters into this lecture. Now, whenever we are talking about the fragmentation, we should be aware about what is the meaning of word fragmentation. Fragmentation means whatever the packets we are sending, it should be divided into the header formats, right? So we can say whenever whatever the IP packet is coming from the upper layer, we have to, when it comes to the next layer, it is being divided into the frames, right? Which includes the header as well as the trailer, right? So into that case, whatever the protocols we are having, this is the size of the units. Just for example, if we are using a token ring, then MTU size is to be a 17,914 bits, right? So similarly, we are going to talk about the fragmentation. First of all, in the case of fragmentation, here we are going to talk about the identification. When I am talking about the identification, it means we have to identify from what is the original source of sending the data. Who is the original host of the data, from where it is being started sending into it. How long it will exist into the main memory. It means how what we are using the counter values. किस तरीके से उसकी counter values हम लोगों को increment में बात करेंगे. Similarly, all the fragments have the same identification number. Suppose whatever the large packet we have divided into the n number of fragments, and each and every fragment is having a same identification number. And why we are providing the same identification number? Because whenever it comes to the receiver side, it is very easy and convenient for the receiver to reassemble the complete one datagram, right? Then after that, we are going to talk about the next bits, that is called as a flag bits. Remember one thing, when I am talking about the flag bits, we are using a 3-bit field, right? This is a 3-bit field. Into this 3-bit field, the first value is never used, right? Right? And after that, these two parameters indicates the different two functionalities of the fragmentation. If we are talking about the first bit, that is D, it means do not fragment. Do not fragment says कि if the value of their machine is 1, if the value of this is to be 1, right? So it indicates that the machine must not fragmented the datagrams. It cannot pass the datagram through any available physical network, right? It discards the datagrams and it sends an ICMP error message to the host source. Clear है? तो हम ये कहते हैं कि अगर यहाँ पे value is 1, then we can say we will not do the fragmentation of the given fragments, right? And if I am talking about the next value, that is it should be either 1 or 0, right? Again, this value should be 1 or 0. If the value is 1, then we can say the datagram is not the last fragment. We are having a more fragments to come, right? So it means if the value is 1, then we can say more fragments are coming. Means इसके अभी और parts बाकी हैं, right? This is not the last fragment, right? And similarly, if the value is 0, if the value of more fragment value is to be 0, this indicates that it is either the last fragment or only fragment. Remember one thing, because initially the value is 0, right? If the value in the initial case it is the 0, we can similarly say that it is only the fragment. We are not aware about it that we did more fragments or not, right? Similarly, we can say if the value is 0, this can be the last fragment also, right? So both the values can be possible in the case of last bit. This is the way how we are setting the fragmentation, right? Now, the last parameter is a fragmentation offset. When I am talking about the fragmentation offset, we have to check the values for the fragmentations, right? In the case of fragmentation offset, this value should be of 13 bits, right? So, if I am saying, I can explain you with an example. Suppose if I say I am sending you a data of 4000 bytes, right? So, it would be very difficult to transmit the 4000 byte data from the source to the destination in a single packet. So, generally we are divided into the n number of packets, and whenever we are dividing the packets into an n number of packets, due to which we always require the fragmentation offset value, right? So, due to which whenever we are having a 4000 byte packet long, we have to divide it into the bytes, right? So, for example, if I say the first packet is of 1400 bytes long, the next packet again is of 1400 bytes long, and the last packet is of 1200 only, right? So 14, 14 and 12 we have divided into the 3 small fragments, right? So due to which we have to generally use to set the offset value. How we have to set the offset value? Generally 1 byte represents the 8 bits, right? That is why whatever from where we have started the bytes, we have to divide it by 8. Why we have to divide it by 8? Because we are using a 1 byte long. If we are talking about a 1 byte, it means we are talking about 8 bits, right? So we have to divide it by 8 if the offset value comes out to be 0. Now after that, we did the fragmentation of the data into the 3 fragments. So first of all, the fragment size is from 000 to 13999, right? So it initially starts from 0. So we will divide 0 divided by 8, the offset value becomes 0. Clear? Then after that, we have finished from 1399 bytes. So we have to start from 1400 till 2799, right? So due to which initial offset value becomes 1400 divided by 8. So from where this byte of fragment starts, the offset will be 175, right? Similarly, we can do the another fragmentation. Its initial stage is 2800. So we divided by 8, that comes out to be the fragmentation offset value should be 350, sorry, right? This is the way how you can do the fragmentations, right? Now in the similar example, if I give you about do not fragment or more fragments, now you can see if I am talking about the original datagram, initially it is a 4,000 bytes long. If it is a 4,000 bytes long, we can say we have to start 0. 0 indicates that this should be the last fragment or only fragment, right? Then we have divided into the 3 fragments. So into this you can check, this is 1, this is also 1. It means this is not the last fragments, more fragments to be come. But this is the 0, which indicates that this is the only fragment or the last fragment. Fine. Similarly, this particular 1400 we have divided into the 700 fragments. So again what we have to do, we have to calculate its offset values, right? And we have to put it 1 1. Why? Because we have not shown that more fragments is to be coming, right? This is the way how we have to do the fragmentation of the data, right? Now let's see some certain examples into the class. First of all, we are going to talk about the first example. In this example, we have to check the complete header format. So in this lecture, we have gone through the complete header format. Now let's do some numericals so that we can understand how we can send the packets or how we can check the header format. The first question comes, an IPv4 packet has arrived with the first 8 bits, right? It shows the first 8 bits as 01000010, right? So it shows the 8 bits. So remember one thing, if I am talking about 8 bits, initially the first 4 bit indicates the version and the next 4 bits indicate the header length, right? So in this example, if I give you the 8 bit date example, right? So you know this first 4 bits indicate version, right? And the last 4 bits indicate length. Am I right? Header length, HLEN, right? First of all, let's check the version. The question asks, the receiver discards the packet. Why? Because this particular bits packet is being discarded. So it is the receiver is asking why we have to discard the packet. What is the reason behind it? So we have to check the error into this packet. First of all, we have to check the version. In the case of version, we know if the value, we convert this particular number into the decimals number. So we came to know the 4 bits. It indicates that we are using the version. Which version we are showing? 4 bits. So if it is this, so it indicates 4. So it means we are using IPv4. So ये तो सही है, right? This is correct. Then after that, the next 4 bits indicate the header length. Now we have to calculate the header length. As I have already told you, whatever the header we have to calculate the total length. It represents into the 4 bit. We have to calculate the value. Now after converting this number 0010 into the decimal, it comes out to be 2, right? If it comes out to be 2, 2 into 4, it comes out to be 8. It means the header length is 8. Is it possible to consist the header length of 8? No, because in the previous header format, we have already gone through that the minimum header length is 20 byte long up to the 60 byte long. So due to which we can say this particular packet is being corrupted in transmission. So there is an error into the packet. Is packet mein error hai? Why? Because the header length is 8 byte long, which is cannot be exist into the case of IPv. Right? Let's see the one more example. If an IPv packet, the value of the header length is 1, 3 times 0 in binary, right? So we have to check how many bytes of options are being carried in this packet. Okay. तो हमें कितने पैकेट्स में ऑप्शंस जनरेट होंगे? We know that if the header length value is 8, right? So we have to convert it into the binary first. Decimal, sorry. We have converted into decimal. It comes out to be 8. 8 into 4. Why we have to multiply by 4? Because header length is 4 bytes long. So it comes out to be 32 bytes. So out of 32, we know header length should either a 20 byte long or for 60 byte long. So out of 32, we have calculated that the first 20 are the bytes of header, right? That is an IPv4. Then rest of the 12 bytes indicates the options. We'll explain you the what types of options will be available into the header format, right? Now you can check the next example. If the IPv4 packet, the value of the header length is 5. If it indicates कि जो हमारी header की length है वो हमें 5 already given है. If it is given, then the value of the total length of the field is 0x0028. So now we have to calculate how many bytes of the data is being carried into this packet, right? As we know, the header length is 5. So we have to calculate 5 into 4. That comes out to be 20 bytes long, right? If it is consist of 20 bytes long, it means there are no options, right? Because the minimum length of the header is 20 bytes. And if it comes out to be 20, it means there are no options. But it says the total length field, if it is being given the total length as this value. So if the total length is given as 40 bytes long, then you can calculate कि after carrying a 20 bytes of header length, then we can say we can calculate the 20 bytes length of data. This is the way how you can calculate the packets, right? Now, next we are going to talk about the TTL value. If an IPv4 packet is being arrived, the first few hexadecimal, it represents in hexadecimal notation. So we have to calculate how many hops can be this packet travel being dropped and the data belong to upper which layer. Now into this case, we have to skip the first 8 bytes because this data is given in an hexadecimal notation. And in the case of hexadecimal notation, each value represents the 4 bits, right? So initially what we have to do, we have to skip the 8 bytes and we have to find the value of TTL. Into this case, the value comes out to be 01, right? The 9th byte will be 01. If it is 01, this indicates that particular packet. 1 indicates converted into the decimal, it comes out to be 1. So it means this particular packet can travel only 1 hop, right? Means this is a source, this is a destination directly. This particular field, the next byte indicates the protocol field. So if the next byte is protocol field, that is, sorry, this is 0202. If it is 02, we know the next byte is 02, it indicates the value 2. And in the case of protocols, you can check also. What is the meaning of word 2? 2. We are using an IGMP. We are using IGMP protocol. So it means in this example, we are using IGMP protocol, right? This is the way how we are talking about the fragmentation. Now, let's see some examples of fragmentation. Suppose there is a packet is being arrived with a M bit, more fragments, and its value is 0. Remember one thing, if the value of the M bit is M, and what is M? M is more fragments. If the value is 0, then we have to, they are asking, is that particular fragment is the first, last or middle fragment? And you have to justify your answer, ki which if the packet was fragmented or not, right? If the value is 0, right? If the value is 0, that it means it is sure that there are no more fragments. But we can say, yes, we can say this is the last fragment, right? Or only fragment. But we cannot say it is fragmented or not, right? So that value we are going to know from D, do not fragment. The next example, if the packet has been arrived with the M bit value of 1, if we are having the M bit value is 1, is this is a first, last or the middle fragment? You have to ask. Yes, if it is a 1, it means there is at least one more fragment. It can be first, it can be middle, but it cannot be the last. Why? Because if it is the last fragment, then the value of the M should be 0. So we can say it can be the first fragment, it can be the last middle fragment, but it cannot be the last fragment. Last example you can see, it is given that M bit value is 1 and its fragmentation offset is 0, right? So due to M, we have seen an example that it can be a first or the middle one. But because it is given in the example that its fragmentation offset value is 0, and we came to know if it is the offset value is 0, then it should be the first fragment. Now in this example, with the help of offset value, you can decide that this is a first fragment, right? The last example we are going to talk about, a packet has arrived with the offset value that is 100. अगर मान के चलिए आपके पास एक पैकेट आता है, उसका ऑफसेट वैल्यू इज 100, then what is the number of first byte? Do you know the number of last byte? Right? Generally we know, if we want to find the first byte, we know we have to multiply the offset value by 8. Why? Because we are dividing it. To calculate the offset value, so we similarly multiply that value, right? So this means if we are talking about calculating this value, we have to multiply it by 8 and its offset value is 100. So what we have to do, 800 into 8, that comes out to be 800. So we can say whatever the data we are sending, the first byte number is 800. But we cannot determine the number of the last fragment, because due to which we require the length. अगर हमें लेंथ नहीं पता होगा, we cannot calculate the last number of that byte. The last example here we are going to talk about, if the offset value is 100, header length is 5, it is given, the total length field is 100, and what are the number of first byte and the last byte, right? First byte calculate करने के लिए we know the offset value, so we have to multiply the offset value with the 8, then it comes out to be 800. It is already given, the total length is 100 bytes, right? So we know total length, that is equals to 100. Then after that it is already given that the header length is 5. If it is 5, it means we have to talk about the 20 bytes header, right? So it means we are using the 20 bytes header, out of which it means we are talking about the 80 bytes datagram. Am I right? So if the first byte is 800, then what will be the last byte? 800 plus 80, that comes to be, or it starts from 800 to 879. This is the way how we have to do the fragmentations, right? Now the last topic we are going to talk about in this question, that is in options. This is the last parameter how we are talking about the different types of options. Options means, it means we are talking about the options. It implies that they are not required by the datagram. They are generally used for the network testing and debugging, right? So it is being divided in the two categories, single byte and multiple byte. If we are talking about the single byte, it is being divided in the two categories, no operation and end of operation. First of all, if I am talking about a no operation option says it is a 1 byte option which is being used as a filler between the different types of options. हम उसको एक filler की तरह use कर रहे हैं, nothing else. Then after that, the next is an end of option. If I am talking about it is a 1 byte long, this particular option is used for padding, right? हम इसको padding के लिए use करते हैं at the end of option, and generally this can be used as the last option, right? Now I am talking about the multiple bytes. The first is called as a record route. Basically this is being used for recording the internet services, internet routers, so that how they can handle the datagrams. ठीक है? In this case we are using for debugging and management purpose. Second, we are using a strict source route. Strict source route says whatever the predetermined source route is being restricted by the source node, we have to follow or we have to travel through the internet into that particular source route, right? The next is loose source route. It works similarly like a strict. Here we are loosely handling the datagrams. Each and every datagram can follow any number of routes and they can visit any number of routers. And the last is timestamp. When I'm using about the timestamp, basically it is being used to record the time of the datagrams processing by the router, right? And this particular time can be in a milliseconds or microseconds from the midnight values, right? And this is the way how you can calculate the timestamp. So these are the various types of options which we are talking into the IPv4 header format. Thank you.